the world's most precious spice. Imagine a spice so precious that it is often called red gold. A spice that is more valuable than silver by weight and treasured across the world for its unique color, aroma, flavor, and medicinal properties. This extraordinary spice is saffron, obtained from the delicate crimson stigmas of the saffron flower. For centuries, saffron has been cultivated mainly in the cool valleys of Kashmir and a few other regions with very specific climatic conditions. But today, a remarkable scientific innovation is changing this centuries-old belief. Scientists are exploring the possibility of growing saffron without soil, using one of the world's most advanced cultivation technologies, aeroponics. Can saffron grow without soil? Traditionally, saffron cultivation depends on fertile soil, cold winters, and dry summers. These environmental requirements have limited its cultivation to only a few regions. But what if saffron could be grown without soil? Aeroponics is an innovative cultivation system where plant roots remain suspended in the air while receiving a precisely controlled mist of water and nutrients. This technology provides the roots with abundant oxygen, efficient nutrient delivery, and complete environmental control, creating ideal growing conditions throughout the year. Telangana's scientific breakthrough. A major step towards expanding saffron cultivation has emerged from Telangana. Scientists at Sri Khanda Laxman Telangana State Horticultural University have established an aeroponics saffron research laboratory at the College of Horticulture, Mojurla, in Wanaparthi district. Their objective is to evaluate whether high-quality saffron can be successfully cultivated under Telangana's climatic conditions using a carefully controlled indoor environment. This research has the potential to reduce dependence on traditional growing regions and open new opportunities for protected cultivation in suitable locations. What you will learn in this documentary. Welcome to this comprehensive A to Z documentary on saffron cultivation in an aeroponics system. Throughout this documentary, we will explore the science behind saffron, understand how aeroponics systems work, learn about the laboratory setup, planting techniques, climate management, flowering, harvesting, processing, quality standards, economics, investment requirements, and future opportunities for farmers and entrepreneurs. Whether you are a farmer, an agricultural student, a researcher, or simply curious about modern farming technologies, this documentary will provide valuable insights into one of the most exciting innovations in protected cultivation. Let's begin our journey into the fascinating world of aeroponics saffron cultivation. Understanding the saffron plant. Before learning how saffron is cultivated in an aeroponic system, let us first understand the plant itself. Saffron is obtained from the flower of Crocus sativus, a perennial flowering plant belonging to the iris family. Unlike many crops, saffron does not grow from seeds. Instead, it is propagated through underground storage organs called corms. Each healthy corm produces narrow green leaves and one or more beautiful purple flowers. Inside every flower are 3 delicate crimson stigmas. These stigmas are carefully hand-harvested and dried to produce the saffron spice that is prized worldwide. Since each flower yields only 3 stigmas, thousands of flowers are required to produce even a small quantity of saffron. Why is saffron so expensive? Saffron is often called red gold, and for good reason. Every saffron flower blooms for only a short period, and the delicate stigmas must be harvested by hand, usually during the early morning hours. The harvesting process is extremely labor-intensive. The flowers are picked one by one, and the 3 tiny stigmas are separated manually with great care. After harvesting, the stigmas are carefully dried to preserve their color, aroma, and medicinal compounds. Because of the enormous labor involved and the very low yield per flower, saffron has become one of the most valuable agricultural products in the world. Challenges of traditional saffron cultivation. Traditional saffron cultivation depends on a unique combination of environmental conditions. The crop requires cool winters, mild temperatures during the growing season, and well-drained soil. It is also sensitive to excess moisture, prolonged waterlogging, and certain diseases affecting the corms. Changes in rainfall patterns, rising temperatures, and other climatic factors can influence flowering and overall productivity. These challenges have encouraged scientists to explore controlled environment cultivation systems that reduce dependence on natural weather conditions and allow more precise management of the crop. What is aeroponics and how does it work? Aeroponics is one of the most advanced forms of protected cultivation. In this system, plants are not grown in soil. Instead, the corms are securely supported while their roots remain suspended in air inside a closed growing chamber. At regular intervals, specialized misting nozzles spray a fine nutrient solution directly onto the roots. This provides water, essential minerals, and abundant oxygen, creating an ideal environment for root development. Temperature, humidity, lighting, and nutrient delivery can all be carefully monitored and adjusted. Such precise environmental control is one of the reasons why aeroponics is being studied as a promising method for cultivating saffron under controlled conditions. Inside the Aeroponics Saffron Research Laboratory. Welcome inside an Aeroponics Saffron Research Laboratory. Unlike traditional farming, this facility is designed to maintain a carefully controlled environment throughout the crop cycle. Every factor including temperature, relative humidity, air circulation, lighting, irrigation timing, and nutrient delivery is continuously monitored. Researchers collect and analyze data to understand how these environmental conditions influence saffron growth, flowering, and corm development. Such controlled environment research helps scientists evaluate cultivation techniques before they are recommended for wider adoption. Components of an aeroponic saffron system. An aeroponic cultivation system combines several integrated components that work together to support healthy plant growth. The growing chamber securely holds the saffron corms while allowing the roots to remain suspended in air. A nutrient reservoir stores the prepared nutrient solution, which is delivered through high-pressure pumps to specialized misting nozzles. Digital instruments monitor important parameters such as pH and electrical conductivity, helping researchers maintain consistent nutrient conditions throughout the experiment. Climate control, creating the ideal growing environment. One of the greatest advantages of indoor aeroponic cultivation is precise environmental control. Climate control equipment helps maintain stable growing conditions inside the laboratory, reducing the influence of external weather. Sensors continuously monitor temperature and humidity, while ventilation systems promote uniform air circulation throughout the growing chamber. Depending on the research objectives, supplemental lighting may also be used to regulate the light environment and support healthy plant development. Selecting healthy saffron corms. Successful saffron cultivation begins with the careful selection of healthy planting material. Researchers inspect each corm for physical damage, disease symptoms, and overall quality before it is introduced into the aeroponic system. Only healthy, well-developed corms are selected for experimental planting, helping to ensure consistent observations during the study. Careful handling and sanitation during this stage also reduce the risk of introducing diseases into the controlled growing environment. Preparing the aeroponic system before planting. Before the saffron corms are introduced, the aeroponic system undergoes a thorough preparation process. Every component, including the growing chamber, nutrient reservoir, pipelines, and misting nozzles, is cleaned and inspected to ensure reliable operation. Researchers verify that the pumps, sensors, and control systems are functioning correctly before beginning the experiment. Proper preparation helps maintain a clean growing environment and supports consistent research observations throughout the cultivation cycle. Planting the saffron corms. Once the system is ready, the selected saffron corms are carefully positioned in specially designed support holders. The holders keep each corm stable while allowing the developing roots to remain freely suspended inside the growing chamber. Proper spacing between corms improves airflow around the plants and provides adequate room for root growth and observation. Correct placement at the beginning of the experiment contributes to uniform crop establishment. Nutrient mist, feeding the plants. Unlike conventional farming, aeroponic plants receive water and nutrients through a fine mist rather than from soil. High-pressure nozzles deliver tiny droplets directly to the suspended roots, allowing efficient contact with water, dissolved nutrients, and oxygen. Automated controllers regulate the misting process according to the experimental design, ensuring consistent delivery throughout the cultivation period. This controlled method enables researchers to study plant responses under carefully managed conditions. Monitoring the crop after planting. Following planting, researchers closely monitor both the crop and the growing environment. Environmental data, plant observations, and system performance are recorded regularly to evaluate crop development. Any variation in equipment performance or plant response can be identified early, helping researchers maintain stable experimental conditions. Careful monitoring is an essential part of scientific research and provides valuable information for improving future cultivation practices. The growth cycle of saffron. After successful establishment, the saffron corm enters its vegetative growth stage. New roots develop rapidly while slender green leaves begin to emerge from the corm. During this period, the plant stores energy that will later support flowering and the formation of daughter corms. Healthy root growth and vigorous foliage are important indicators that the crop is adapting well to the controlled aeroponic environment. Scientists regularly document these developmental stages to understand the crop's response under protected cultivation. Environmental monitoring and crop management. Maintaining a stable growing environment is one of the key advantages of aeroponic cultivation. Researchers continuously observe environmental conditions and plant performance throughout the experiment. Automated monitoring systems provide real-time information that helps maintain consistency within the growing chamber. Careful observation allows researchers to evaluate how different environmental conditions influence plant growth and flowering, contributing to the development of improved cultivation practices. Flower initiation and blooming. The most exciting stage of saffron cultivation is flowering. As the flower buds develop, vibrant purple blossoms gradually unfold, revealing the plant's most valuable feature, the three delicate crimson stigmas. Because each flower blooms for only a short period, researchers closely monitor flowering to record its timing, duration, and quality. The appearance of healthy flowers represents an important milestone in evaluating the success of controlled environment cultivation. Scientific evaluation of crop performance. Scientific research goes beyond simply producing flowers. Researchers carefully evaluate plant growth, flowering characteristics, and corm development to understand how the crop performs under controlled conditions. Detailed observations and accurate record-keeping help compare different cultivation methods and identify opportunities for future improvement. These findings contribute to ongoing research aimed at refining aeroponic saffron production and supporting evidence-based recommendations for protected cultivation. Harvesting the precious saffron flowers. The flowering stage marks the beginning of the most delicate operation in saffron production harvesting. Fully opened flowers are carefully picked by hand to prevent damage to the fragile petals and the valuable crimson stigmas. Gentle handling is essential because bruised flowers can reduce processing efficiency and affect the final product. Once harvested, the flowers are transferred immediately to a clean processing area where the stigmas are separated without unnecessary delay. Separating the valuable crimson stigmas. Each saffron flower contains only 3 crimson stigmas, the part that becomes the commercial spice. The stigmas are carefully separated by hand using clean tools and gentle movements to preserve their natural shape and color. Since this process is entirely manual, it requires patience, skill, and attention to detail. The quality of the harvested stigmas at this stage has a major influence on the appearance and value of the final product. Drying, preserving quality. Fresh saffron stigmas contain a significant amount of moisture and must be dried carefully to preserve their valuable compounds. Controlled drying helps maintain the characteristic color, aroma, and flavor for which saffron is renowned. Excessive heat or improper drying can reduce product quality, while careful processing helps retain the spice's premium characteristics. After drying, the saffron threads become lighter in weight, intensely aromatic, and ready for quality evaluation. Quality grading and packaging. The final stage is quality evaluation and packaging. Researchers examine the dried saffron for its color, aroma, cleanliness, and overall appearance before documenting the results. High-quality saffron is carefully packed in clean, airtight containers to protect it from moisture, light, and contamination during storage. Proper harvesting, processing, drying, and packaging together determine the market value of this extraordinary spice, making every step in the production chain equally important. Economics of aeroponic saffron cultivation. One of the most frequently asked questions is whether aeroponic saffron cultivation can become commercially viable. Although research has demonstrated that saffron can be grown in a controlled environment, commercial success depends on several factors, including infrastructure costs, energy consumption, productivity, operational efficiency, and market demand. As research progresses, detailed economic analyses will help determine whether this technology can be adopted on a larger scale for commercial production. Advantages and challenges of aeroponic saffron. Aeroponic cultivation offers several potential advantages. It enables precise environmental control, efficient use of water, reduced dependence on agricultural land, and cleaner growing conditions. However, the technology also presents challenges. It requires specialized infrastructure, uninterrupted electricity, technical expertise, regular equipment maintenance, and careful monitoring. Like any advanced agricultural technology, successful implementation depends on proper training, scientific guidance, and efficient system management. Future opportunities for farmers and entrepreneurs. If ongoing research continues to produce encouraging results, aeroponic saffron cultivation may create new opportunities for protected agriculture, research organizations, entrepreneurs, and skilled growers. Future developments may include specialized training programs, demonstration units, and technology transfer initiatives. Collaboration among universities, government agencies, startups, and private industry could play an important role in expanding knowledge and encouraging innovation in high-value crop production. The future of saffron cultivation in India. Innovation has always been the driving force behind agricultural progress. Research into aeroponic saffron cultivation represents another step towards exploring new possibilities for high-value crops under controlled environments. As scientific studies continue and technologies evolve, the lessons learned today may contribute to more efficient, sustainable, and resilient agricultural systems in the future. With continued research, collaboration, and responsible technology adoption, India has the opportunity to strengthen its expertise in protected cultivation and advanced horticultural production. Complete journey of aeroponic saffron cultivation. Let's quickly revisit the complete journey of saffron cultivation in an aeroponic system. The process begins with selecting healthy corms, followed by careful preparation of a clean aeroponic growing system. The corms are established inside a controlled environment where nutrient mist, air circulation, and environmental monitoring support plant growth. After flowering, the valuable crimson stigmas are harvested, carefully dried, evaluated for quality, and packaged as one of the world's most valuable spices. Every stage demands scientific precision, careful observation, and attention to quality. Key learnings from the documentary. This documentary has introduced the scientific principles behind aeroponic saffron cultivation, the biology of the saffron plant, laboratory infrastructure, controlled environment management, harvesting, processing, and quality evaluation. It has also highlighted both the opportunities and the challenges associated with this emerging technology. Continued research and practical experience will play an important role in refining cultivation methods and supporting future adoption. The future of high-tech agriculture. Agriculture is entering a new era where science, engineering, and digital technologies are working together to improve crop production. Controlled environment agriculture, automation, sensors, and data-driven management are opening new possibilities for cultivating high-value crops. Aeroponic saffron research demonstrates how innovation can expand knowledge and inspire future solutions for sustainable agriculture. Closing message and call to action. Aeroponic saffron cultivation is an exciting example of how scientific research is exploring new possibilities for high-value crop production. While further studies will continue to refine this technology, today's research is helping shape the future of protected cultivation. We hope this documentary has expanded your understanding of saffron and inspired you to appreciate the role of science in modern agriculture. If you found this documentary informative, please support Farm Tech Solutions by liking this video, sharing it with fellow farmers, students, and researchers, and subscribing to our channel for more agriculture and horticulture documentaries. Thank you for watching. See you in our next video.